Let us look at some illustration on work done by a constant force. A porter lifts a suitcase weighing 20 kg from the platform and pulls it on his head 2 meters above the platform. Calculate the work done by the porter and the gravity on the suitcase. Once again, listen to the problem. A porter lifts a suitcase weighing 20 kg from the platform and pulls it on his head 2 meters above the platform. You have to calculate the work done by the porter as well as work done by the gravity on the suitcase. For solving this problem, as you know that the suitcase initially was at rest on the platform and finally also it is at rest on the head of the porter. So initial and final kinetic energy of the suitcase is zero. Whenever suitcase is lifted by a porter, force of gravity acts in vertical downward direction. Since displacement of the suitcase is vertically upward and force of gravity is vertically downward, so angle between force of gravity and displacement of suitcase is 180 degree. So work done by gravity in this situation is equal to mgh cos 180 degree equal to minus mgh. Taking value of g equal to 9.8 meter per second square, work done by gravity in this situation is equal to minus 392 joule. Whatever work is being done by the gravity, opposite work is being done by the porter. So work done by the porter is 392 joule in this situation. Let us look at one more illustration. A box is pushed through 4 meters across a floor offering 100 Newton resistance. How much work is done by the resisting force? Since in this problem work is being done by the resisting force, and we know that the resisting force always acts opposite to the direction of displacement. So in this situation, angle between resisting force and direction of displacement is 180 degree. So work done by the resisting force is equal to F cos 180 degree, that is equal to 4 into 100. Cos 180 degree. In this situation, work done equal to 100 into 4 into cos 180 degree, that is equal to minus 400 joule. Why minus? Because this is the work done by the resisting force. Let us look at one more illustration on work done by a constant force. As shown in figure, a block of mass 5 kg slides down an incline of inclination 30 degree and length 10 meter. Find the work done by the force of gravity when the block reaches from the highest point to the lowest point. As shown in figure, weight mg acts in vertical downward direction. Since surface is smooth, so mg sin 30 degree will act along the incline. Displacement of the block is 10 meter. So work done by force of gravity is equal to 5g sin 30 into 10. Substituting value of g equal to 9.8 meter per second square, we find work done by force of gravity equal to 5 into 9.8 into half into 10, that is equal to 245 joule. Let us look at one more example. A constant force of 2.5 Newton accelerates a stationary particle of mass 15 gram through a displacement of 2.5 meter. Find the work done and the average power delivered. What is average power delivered? Average power delivered is equal to work done divided by time interval. For solving the problem, since a constant force of 2.5 Newton is acting on a body which accelerates the particle, which is in the beginning in rest position and having mass 15 gram, and displacement of the particle is 2.5 meter, work done can be written as force into displacement. So work done in this situation is equal to 2.5 into 2.5, because angle between force vector and displacement vector is 0 degree. So work done in this situation is equal to 6.25 joule. Now let us calculate the average power. Since displacement of the particle is 2.5 meter, initial velocity of the particle is 0, force is constant, so acceleration will also be constant. So apply uniform acceleratory motion equation S equal to ut plus half at square. So we get 2.5 equal to 0 plus half at square. What is acceleration? Acceleration is equal to 2.5 divided by 15 into 10 to the power minus 3. Because 15 gram is equal to 15 into 10 to the power minus 3 kilogram. So we get T equal to 0.1732 second. Now average power is equal to work done divided by time taken. That is equal to 36.1 upon 0.1732. That is equal to 36.1 watt. Let us look at one more illustration. Suppose a man keeps a weight on his head and move ahead in horizontal direction with constant velocity. What is work done in carrying the block? Since weight of the block acts in vertical downward direction and displacement of the body is in horizontal direction, so angle between force vector and distance vector is 90 degree. So work done in carrying a block which is kept on the head of the man is 0. Always remember, whenever angle between force vector and distance vector remains 90 degree, work done remains equal to 0. In case of uniform circular motion also, work done is also 0.